So this is a part of our pain science module, and it is on the gate control theory and descending analgesia. There are two slides, and you will find that they are quite dense in terms of the learning that will be required of you. But remember, you don't need to remember the detail of the biochemistry and the neurology of this. The practical application will be in another session, and that's what you'll be bringing into your practices and your teaching and your sessions. So it's important to note that at the moment, and for many decades, the gate control theory has been just that, a theory. It has been not possible to fully confirm that it is the case through research. I'm not quite sure why, but it has not been possible. However, it is such a well-established and respected theory that many papers or studies on pain take it um, a- as a definite. It's widely believed and for some reason difficult to study. I'm not quite sure why. However, the descending analgesia is something that is in the research. So the reason it's in here is that it is something that we can use to help to reduce pain, and that's a big part of neurosoma yoga, as you know. So the jaggedy line here, the reddish jaggedy line is representing a nociceptor, which you have learnt is a danger receptor. I nearly made my usual slip or my old slip of it's a pain receptor. No, we're not receiving pain. We're receiving signals of danger that travel up the nociceptors to the brain where it analyzes what it has heard or experienced and sends a signal back down the nociceptors, which create a sensation of pain, which is basically saying, stop it, don't do that again. These more gentle, wavy, lovely receptors, though they're actually faster and bigger than nociceptors, are different receptors, particularly for touch, which is a really important part of the gate control theory. Here in the dorsal horn of the spinal cord, we have a gap between neurons. So there is a space, a synapse, where a signal must jump from neuron to neuron. And this is where the gate control theory is all centered, whereby it is believed that possibly the thing we do automatically, which is touch, which stimulates a faster and bigger neuron, will jump the gap sooner and flood the brain with the sense of the touch. And that is what the brain prioritizes to listen to. But there is another part of the theory, which is that this touch receptor then sends a little tributary neuron out, a signal down a tributary neuron, which floods this gap with a particular type of inhibitory substance, which stops this signal jumping from the nociceptor to its fellow nociceptor to continue the signal back on to the brain. So whether it is stimulating those touch receptors that floods the brain, or that it is the signal traveling up those touch receptors causes this collateral or tributary little neuron here to send in inhibitory substances into that synapse, we do know that touch matters. There are lots of things we already, well, this what we naturally do often is if we bang an elbow, we touch, we rub, and we might also use something warm like a hot water bottle, or even ice might make it feel better because it numbs the receptor response. But there are also things that in a longer term have been seen to reduce pain, like TENS machines or light touch or deep massage, manual therapies, acupuncture. acupuncture works on as far as I know, many different levels, but maybe it is in part just the sensation and the response in the body to, oh my goodness, there's a needle going in there. Of course, there's the whole issue of chi lines and energy that I don't understand, that some of you might. Um, then the list towards the end is more related to our descending analgesia. So before I get to that, we'll just talk a little bit about what we can do or what we would tend to do to try and stimulate the touch receptors. The priority is thinking back to your homunculus or your sensory motor cortex and how parts of the body are more or less represented in that sensory motor cortex. Take a moment now to think, can I remember which parts of the body had a bigger mapping in the brain? I'm going to let you think about that. And now I'm going to remind you. So the hands, the feet, would be particularly well represented alongside the tongue. Massaging the tongue is not very pleasant. So we would maybe think about massaging the hands or feet. And I certainly would do quite a bit of that in my classes. Joints have a high number of those bigger somatosensory receptors. And so that is quite a useful thing to either massage the joints or even move the joints to get them stimulated. We'll do some practical gate control theory activities in the next session. So descending analgesia is where we can bring the brain to influence the experience of pain. In the pain science video with Diana, you've already learned about attitude, expectation, and how important this is. So, really, descending analgesia is a little less cognitive, but it is certainly influenced by such things. So, thinking about lovely memories, I've got a lovely picture of a beach here. By the way, this image is not from me. I didn't make that image of the lovely holiday beach. That is from this website here. And please remember that if you are using any of these slides, you should credit Diana and me and Neurosoma Yoga, but also if you are using slides where I've credited another body, you need to be more careful about that as well, about crediting where the image comes from. So the idea is that with descending analgesia, it's trying to help us be able to manage the pain. Because if we just get flooded with pain and we can't do anything, we are powerless to do what needs to be done to stay safe. So mostly it's about the brain trying to save you from getting into more trouble rather than it caring how much pain you feel in terms of, oh no, we don't want that to happen, you poor thing. Stimulating the brainstem would arguably be supportive of descending analgesia because that is the area where descending analgesia is stimulating the secretion of the hormones that then travel down into that same place where we saw the gate control theory inhibition, that it floods that space with serotonin and other opioids, which are essentially painkillers. How amazing is that? And that is the idea that it could be part maybe of the gate control theory, that it is interrupting those signals, just like the theory of it being interrupted on the way up, the afferent signal. So this is more affecting the efferent, the signal from brain down and out to the ends. I could detail the different parts of descending analgesia and the brainstem. There's different parts of the grey matter in the brainstem, but I don't think that's important. I think what's important is to remember the benefits of maintaining levels of the feel-good hormones, which we have talked about, and that there are routes to do that, which I always think is a really important piece. But also, there are nuclei within the limbic system that are influenced here, which help control the motivational or behavioral responses to pain as well as the emotional response to it. So, modulating the limbic system responses through meditation or through the choice to interrupt habitual reactions with voluntary reactions and voluntary thoughts is of value to our experience of pain. Um, just wanting to check my own notes to make sure that there is anything I have missed. Yeah, so serotonin optimization, as I've talked about, clear input so that the brain is in a state to be able to or to accurately analyze what is actually being what signal is being sent to the brain, what the level of danger is, so that afferent signal, the brain wants to be able to interpret it properly, and then inducing feelings of safety like self-talk, I'm okay. So there's that cerebral input to something that is actually biochemically happening in the brain stem, and also potentially distraction. So maybe doing some neurological drills, some coordination drills, etc., like the VW that you've learned, will help to distract from the pain. So it's not patronizing to suggest that that can be of value. Diana will have talked or be talking about the role of the PMRF, the pontomedullary reticular formation, and the brainstem, and how to support them, which is significant to this process. Thank you so much, and look forward to making that maybe more interesting to you as we work with techniques to support the gate control theory, and remembering, of course, the role of the feel-good hormones and supporting them.